Since I know you guys are all ready, no one's playing with their phone right now, so let's go with class.
Yes.
Ooh, excellent. Thank you. So, 2.3, the derivative of a polynomial function and the derivative of y equals e to the x. Now, that one sucks. And there's a proof for it, and I did it once, and I'm never doing it again. So don't ask. All right. So, find the derivative of a function at number c. So now, let's pretend this. Let's pretend like this is my function, y equals 3. What's the slope of that line? 0, right? Because there is no x. And we know that the derivative gives me the slope, right? It's going to give me the slope. But the problem is, so if it's any constant, what is the derivative? So this is a constant right here. Constants have no variables. So this, my slope, in this case, so y prime would be 0. So I know that is a straight horizontal line. Super easy, right? Okay. Now, if it's f of x, let's pretend like I remembered back in Algebra 1. What is the slope of f of x equals x? What's the slope of this? 1. Why is it 1? There is, it's implied, right, that there is a number 1 in front of that. So for f of x, it's actually a 1x. It's a number in front of it. It's implied, right? So, and then like plus b right here, right? So that's like the y equals mx plus b. So all I'm asking for now is the slope of the line if it's just y equals x. So it's the number in front of that. Yeah? That's pretty easy, right? Okay. Here is my formula for this. Someone pointed out the other day that it should be 1 degree less, shouldn't it? I don't remember who that was, but yeah. So it's always 1 degree less. So this is the rule for that. And I'll explain what all this means here in a minute. And I prefer doing this with actual values instead of actually trying to explain this. So I have my function I'm going to find. So this is the notation that says I want the derivative of that. So if I want the derivative of that, it is x to the 4th. So from my formula that I just had the previous slide, that 4 is my n. So that is going to go out front. And then what did I do to my n value? Subtract 1. So this is my, in this occasion, that is the derivative. Is that pretty easy now?
And does that work for every single one?
Every single one,
Really?
except for e to the x. But that has rules. Log rules are different also. But when we're just dealing with regular basic polynomials, then yeah. All right, let's do the next one then. So if I have g of x is x to the 10, g prime of x would be, say the whole thing. Ah, swing and miss. What'd you forget?
G prime.
No?
Okay, d over dx.
No. No, that's just telling you what to do.
X 10 minus 1.
No.
10x to the power.
10x. So if you look right here, where'd the 4 go?
So that could
Oh.
be 10x?
There we go. So yes, that's going to be 10x raised to what power? 9. So this is why I like using this one, to show where those numbers go and what happens to those numbers instead of just showing you your n's and your n's minus 1. Is that pretty easy now? Now, let's look at that problem that we were just having a problem with from the homework. Wasn't it f of x equals x cubed?
Yeah. Then the answer was 3x squared.
So f prime of x, 3x squared.
How about the 1 over x?
How about the what?
1 over x.
It's not just x to the power 1 half.
So, for this to work, everything has to be in the numerator. Okay, so I have to move that. To the numerator. So right now it's in the denominator, so you guys got to use the rules. If it's moving across the divisor, it changes its sign. So if it's a positive 1 down here, if it moves up to the numerator, it becomes negative 1, right? So it'll change its sign. So it's going to be f of x is x to the negative 1. Do you agree that?
But can you explain that one?
Okay, this is a rule that always applies. If you move something across the divisor, okay, in something like this you can't, because, you know, it goes up there. So it's basically 1 divided by x, right? So isn't 1 divided by the x the same as multiplying by the reciprocal? Yes, it's multiplying by the reciprocal. So it's the same thing. So I just need to show this by moving it. So right here it's a positive. Up there it will be a negative.
Is that the same if the x had a constant, like a 2 x?
You would leave the 2 alone in the bottom.
It would still be at the bottom.
Yeah, you would still leave that. It's just our variable. Everything goes by our variable, not whatever number's in front of it, not the coefficient. It's just the number, just the variable. Okay. All right. So now let's use the same rule.
Bring it down.
F prime of x will give me a negative 1.
X squared. Negative 2.
Negative 2. Very good.
Negative squared.
Okay, so negative 2. Now let's clean it back up. We could put it back where it goes. It goes where? It goes to the bottom, right? I want to try and show positive exponents, so I'm going to put that back where I got it. So f prime of x is negative 1 over positive x squared. Isn't that what I had?
Yeah. So you always keep it, don't keep that like a fraction, try to always keep that like simple like that.
Okay.
Is that what you try to do?
Try it again. I'm not understanding what you're trying to say.
Is the goal to always like there's an exponent within a fraction? Is it the best way to like to transform it into?
Yeah, put it in the numerator because that's where our rules work. It's not the same in the denominator. Our rules that we have for this is always in the numerator.
You just have to shape it to yourself.
Yep. So we have to manipulate it first, then we can do it. All right. Okay. I am going to pick up on this tomorrow. I'm going to give you guys this time now. Hopefully you can finish up 2-2 and work on some of 2-3. Make sure you guys all like, share, and subscribe. I updated my channel. My YouTube channel has my new website. So yeah, there is new merch on there.